Good evening. We're going to begin tonight's presentation by first reviewing the homework that was assigned last week, last Tuesday, January 28th. The three homework problems that we had were Appendix 2A1, or Problem 2A1 in the appendix of Chapter 2. Then we had Exercise 3-10 and Exercise 3-12, as well as Problem 3-26. Alright, we want to begin reviewing this homework right now. If you turn the book to page 69, Exercise 2A1 involves a problem where we need to solve least squares regression for the Easy Rental Car Company, who offers rental cars in an off-airport location. We've all seen these types of places, near a major tourist destination in Florida. Management would like to better understand the behavior of the company's cost. One of these costs is the cost of washing cars. The company operates its own car wash facility in which each rental car that is returned is thoroughly cleaned before releasing it for another rental customer. Management believes the cost of operating the car wash should be related to the number of rental returns. Alright, so if you look at the bottom of page 69, we have this schedule by month of rental returns and car wash costs. Loading this information into Excel, alright, just as we have setting up a spreadsheet, as you can see here on the screen, and we then need to go and calculate the intercept, the slope, and the R-square, because the requirement at the top of page 70 says using least squares regression, estimate the fixed cost and variable cost elements of the monthly car wash costs. The fixed cost element should be estimated to the nearest dollar, variable cost element to the nearest cent. Alright, walking through this problem, if you recall last week we discussed how to do this, that we put the cursor in the intercept box. We go up in Excel to More Functions, we select Statistical, and we scroll down to Intercept. Intercept is the A in the y equals a plus bx equation, and that A represents the total fixed cost. Now what we need to do is insert the known y's. Y is the dependent variable measured by car wash costs. X is the independent variable measured by the rental car returns. We highlight those items, select OK, and we have our total fixed cost of $2,296.40. Now we do the same for slope. Put the cursor in the box, scroll down to slope. Once again, the known y's is the same thing, total car wash costs. Known x's, rental car returns. Click OK, and we have our variable cost per unit, or B, of $3.74 per car wash. Alright, so for each rental return, it costs $3.74 of rental of car wash materials. Okay, we then need to calculate the R-square. The R-square gives us the goodness of fit, okay, or really the reliability of this equation. We select R-square, do the same as we did, the known y's, the known x's, click OK, and we get 0.92 or 9167, which is a very good R-square. Therefore, our equation is as such: y equals 2296.40 plus 3.74x. Therefore, the total cost, as this company would like to know, they would like to know the cost of operating the car wash is related to number of rental returns, alright, and we therefore can predict the total car wash cost going forward based on the number of rental returns, that the equation would be $2,296.40 of fixed cost, plus for every rental return we have, another $3.74, which added together gives us the total car wash cost for that particular month. This does it for our discussion of solution to the exercise 2A-1. Okay, the next problem we had to do for homework was exercise 3-10, which is at the end of chapter 3 on page 116. If you look at this problem, a company assigns overhead costs to completed jobs on the basis of 120% of direct labor cost. The job cost sheet for job 413 shows that $12,000 in direct materials has been used on the job and $8,000 in direct labor cost has been incurred. A total of 200 units were produced in job 413. The requirement of the problem is to find out what is the total manufacturing cost assigned to job 413, and then what is the unit product cost for job 413. Well, this problem is a somewhat basic problem in dealing with calculating total product cost and applying overhead based on whatever cost driver the company uses. We are given, as you can see here, the direct material cost of $12,000. We're given the direct labor cost of $8,000 on this job number 413. In order to determine the amount of overhead, we need to take the direct labor cost on this job of $8,000 and multiply it by 120%. In other words, this company says for every dollar of direct labor cost they incur $1.20 of overhead for this particular job. Therefore, when we multiply $8,000 times 120%, we get overhead applied of $9,600. When we add these three figures together, the direct material, direct labor, manufacturing overhead, we get a total manufacturing cost of $29,600. So total manufacturing cost, $29,600. There were 200 units in job number 413. We take that total manufacturing cost of $29,600 divided by 200 units, and we come up with $148 per unit. This does it for our discussion of exercise 310. We will now begin our discussion of exercise 3-12. Exercise 3-12, we were required to perform or to calculate parts 1 and 2 of this particular problem. If you look at this problem on page 117 at the end of chapter 3, it deals with Cody Corporation, who uses a job order costing system and uses a plant-wide overhead rate based on machine hours. So machine hours are the cost driver for overhead. At the beginning of the year, the company made the following estimates. Note, this is the beginning of the year. They expected to incur 150,000 machine hours with total fixed manufacturing overhead cost of $750,000 and a variable manufacturing overhead cost per machine hour of $4. We are in Part 1 required to compute the predetermined overhead rate. Now this problem makes us work a little bit because in order to come up with that predetermined overhead rate, we need to know what the total manufacturing overhead cost is. All they tell us is the fixed manufacturing overhead cost is $750,000, and they tell us that the variable manufacturing overhead cost is $4 per machine hour. If you recall, the formula to calculate a predetermined overhead rate is estimated total manufacturing overhead divided by the estimated total machine hours in this problem, since we're using machine hours. Therefore, for us to calculate the total manufacturing overhead, we must take the fixed piece of $750,000 and add to that the variable estimated total variable manufacturing overhead. They expect 150,000 machine hours, and they expect $4 per machine hour. Therefore, $600,000 of variable manufacturing overhead cost. If we take our $750,000 plus the $600,000, we have estimated total manufacturing overhead cost of $1,350,000. So in most problems, as we've seen, we're given this $1,350,000. They made us work a little bit. Remember that fixed manufacturing overhead plus variable manufacturing overhead equals total manufacturing overhead. Therefore, to calculate our predetermined overhead rate, we must take the estimated total manufacturing overhead of $1,350,000, which we just calculated, divide that by our estimated total machine hours of 150,000 machine hours to give us a predetermined overhead rate of $9 per machine hour. $9 per machine hour. Therefore, the answer to Part 1, our predetermined overhead rate, is $9 per machine hour. Part 2 asks us that they have a job number 500 was started and completed during the year. And they give us some information with respect to the job. They tell us the total direct materials on that job of $350. They tell us direct labor cost of $230. And they tell us machine hours used of 30. Therefore, in order to calculate the cost of this job, we will take the direct materials of $350 plus the direct labor of $230 as given in the problem, and we will calculate the total manufacturing overhead to be applied on this job of $9 per machine hour multiplied by 30 machine hours, total manufacturing overhead $270. Total manufacturing cost on job 500 will be $850. The $350 plus the $230 plus the $270, $850. This does it for our discussion of solution to exercise 312. Okay, we'll now begin our discussion of problem 3-26, which is on page 125 and 126. This involves a company named Woodgrain Technology, which makes home office furniture. And there are two departments in this manufacturing facility: a preparation department, which bases its overhead on machine hours, and a fabrication department, which allocates or determines its predetermined overhead rate based on direct labor hours. That first chart on page 126 gives us a chart for each of the preparation and fabrication department as for some estimates that they expect in the coming year. Below that, they talk about job number 127, which was started on April 1 and completed on May 12th. And they give us some actual cost in each of the departments, preparation and fabrication, for this particular job 127. In this problem, we were required to do parts 1, 2, and 3. Part 1 asks us to compute the predetermined overhead rate during the year in the preparation department, and also the predetermined overhead rate in the fabrication department. Part 2 asks us to calculate the total overhead cost to be applied to job 127. Part 3 asks us for the total cost for job 127, and if the job contained 25 units, what would be the unit product cost. Given that, okay, to calculate our predetermined overhead rate, this is done just the same way as we did exercise 3-12. Alright, we are given some parts. Alright, we are not told the total manufacturing overhead cost. We need to take for the preparation department, the fixed manufacturing overhead of $256,000 plus the total variable manufacturing overhead that we expect. We're told in the book that the variable manufacturing overhead per machine hour is $2. We're also told that we expect 80,000 machine hours in the preparation department. Therefore, we expect $160,000 of variable overhead. Given that, we expect our estimated manufacturing overhead cost to be $256 plus $160, or $416,000. We also, based on that, to calculate our predetermined overhead rate, we will use that same $416,000 of estimated manufacturing overhead, divide that by our total machine hours of 80,000 machine hours to come up with our predetermined overhead rate of $5.20. So if we take the $416,000 divided by 80,000, we come up with $5.20 of our predetermined overhead rate for the preparation department. Next thing we have to do is calculate for part 1 is the estimated total manufacturing overhead cost for the fabrication department. We're told that there's $520,000 of estimated fixed cost. All right, we're told that. It's given right in the chart. We're also told that the cost drivers direct labor hours for the fabrication department, and they expect 50,000 direct labor hours. Once again, that's given. And they say that the overhead should be applied, or the variable manufacturing overhead per direct labor hour is $4. $4 times 50,000, we get $200,000 of estimated variable manufacturing overhead. Added to our estimated fixed overhead of $520, we end up with estimated total manufacturing overhead cost of $720,000. That's $720,000 divided